Hello everyone. Today we are going to cover the section in your FE manual regarding the truss deflection using unit load method. Unit load method actually is also called as a virtual load method. Okay, so what are the things that you need to consider in this section is a truss deflection at a joint due to the external applied load, due to the temperature change in the member, and due to the misfit or fabrication error in your member. Okay, so those are the three cases that should know how to apply using unit load method to find the truss deflection at each joint. Okay, so here this is from your FE manual example. It is the equation given in your FE manual is that delta joint is equal to summation of all the forces Fi, which is your uh, virtual load or force member caused by a unit load, and delta L is the change in the length for each member. And if you are going to use, if the load is uh, apply on a truss, or this change is caused by an external load, then you're going to use this formula. You're going to replace delta L with this formula. And if it is the cause of deflection is due to the temperature change, then you're going to replace delta L with this formula. And if it's due to member misfit, then you're going to replace delta L with that member misfit. Okay, so the question, first thing is you need to know the sign convention. Tension, it is given there that tension is positive, and increase in length is going to be positive. Okay, so the first thing, let's talk about F. What is this small f? This small f is, let's say that you have a beam, or you have a truss, and you are interested to find let's say you're interested to find a deflection along this joint B, and you want to find the delta H. Okay, so how much is the deflection, horizontal deflection at the joint B? So the way you find this small f, which is your force member due to the unit load, is by redraw the whole truss structure and remove all the external load. Okay, remove everything, like just draw the structure, and then you are going to apply a unit load in the direction of the deflection. So if you assume that your deflection is in this direction for delta H B, then you apply also the unit load in that direction. Okay, so and then once you have that, then you'll find what is this F, 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 and what is this F. And so the small letter F is member forces caused by the unit load in a truss in the direction of the deflection. And then what is this capital F? Capital F for the same truss. Let's say that you have a same truss and you're applying a load P1 and P2. All these are external load. And so what you're going to find for this is all of these will be capital F, capital F, capital F, capital F, capital F, capital F, capital F. So you're going to find the member force for each member in your truss caused by the external load. So capital F is a member forces caused by the external load. And then in this temperature change, if delta T increases or rise, what it'll do is will increase in length. And because it is increased in length, we'll consider that as your positive. So if delta T is increasing in length, then delta T will be positive. And if delta T is dropping or in decrease or reducing, it will lead to decreasing in length. So if it is decreasing in length, then we say that it's going to be compression, which is your negative. What about uh, the member misfit? The member misfit, if it's too short, then it'll be negative, and too long will be positive. What does it mean by too short, too long? So you'll say that, let's say that your original length that you required is 4 meter, but what you receive from the factory is 4.1 meter. So you'll say that your delta L will be 0.1 meter too long. Okay, so what you required is 4 meter, but what they provided to you is 4.1. So that means that extra delta L will be too long. So delta L will be 0.1, and it will be too long. And because it's too long, it's going to be positive. And if it is too short, then it's going to be negative. So those are the sign convention that you need to remember when solving the truss deflection using unit load method. So in this case, let's say that in this case, it is given that your member force of your truss is given to you. These are all your member forces, which is C compression, this is tension, this is tension. All these member forces are caused by this external load. Okay, so now what we are interested is to find the horizontal deflection at D, which means that this is a deflection of a joint D in horizontal and joint D. Okay, so generally the way I name it is delta, capital delta, H mean horizontal, V mean vertical, and so at a joint and D. So that's what we are interested. So summation of all the force member. So remember that there are AC, CB or BC, CD, AD, and BD. So there are 5 member forces. Okay, so now we need this AE, and AE is giving you to be a constant value. So if it is a constant value, then AE will be equal to, your area is 1 inch square, and E is 29 10 to power 3 KSI, which is kips per square inch. And if we multiply them together, you'll get 29 10 to power 3 kips. So that will be your AE value. Okay, and now for the length, so we know that this is 15 feet and this CD is 20 feet. So that means this has to be 25 using Pythagoras theorem. That means the length AD and length BD has to be 25 feet. So we know the length, we know AE. Now, how do we find the member forces? These are the member forces for capital B, capital F. Remember, capital F is the member forces due to external load. Okay, so this is due to external loads, and this is due to unit load. Okay, so I'm going to show you how to find small f. So in this case, this will be FBD, this will be FBC, and this will be FAC, and this will be FAD, and this will be FCD. So because FCD is equal to 0, so basically we can say, finally we can say that your delta HD, sorry, delta HD, and AE is constant, so we're going to leave AE outside, and then we're going to put F, capital F, L, AC plus F, and then BC plus F, AD plus BD. Okay, so those are the values that we need, and this value are known to us. If AC is tension, so it'll be 29.75, and then BC is also tension, it'll be 29.75, and then AD is compression, so that will be minus 49.6, and then BD is also in compression, so it'll be minus 2.91 kips. Okay, so those are all the values that we have so far in your question, and now we are going to find the unit load. Okay, so for finding the unit load, all you have to do is we draw again the truss member. This is to find F due to unit load, and because we are interested to find the horizontal load, we can assume that this horizontal load will go in this direction and we'll apply a unit load. Okay, so this is the assume delta HD direction. Okay, so we assume that delta HD will be um, towards your left. Okay, and now we are going to find all the, now we are going to use equilibrium equation to find all the support reaction. So this will be your Py, this is Px, and this is Ay, and if we take summation of Ma equal to 0, you'll get By, this is 15 feet, this is 15 feet, and this is 20 feet, and this will be 25 feet, and this will be 25 feet, and this will be my theta, this also be my theta. So our sine theta will be equal to 20 by 25, and our cos theta will be 15 by 25. So the summation of all MA will be By into 30 because it is counterclockwise, so it's positive. And then we have plus 1 into 20. Again, this is counterclockwise. We generally follow the counterclockwise. Moment will be equal, is positive, and then that will be equal to 0. So finally, we'll find that your By is equal to minus 2 over 3. So, or 2 over 3 in the downward position. This makes sense. Just imagine that this is your all your truss structure, and because it's truss structure and you're going to apply in this direction, this will go up. You can see that this joint will go up. So if this joint will deflect up, then your reaction has to come down. So which is what that basically say uh, By is negative, which means that it'll be opposite to what we assume. Okay, so that's how we know that our value is correct. Our sign and the value is correct. And then once we find By, which is what we want, and then here going to say summation of all y equal to 0, and in this case Ay is up, that means positive, plus By also is up, so we'll assume positive is equal to 0, and we already find that our By is negative 2 over 3. So basically we say that our Ay is equal to 2 over 3. Okay, all this unit in kip, but generally I don't write because I want because I'll make sure that, or I'll ensure that all my units are in kips and feet. Okay, once we have that, then we take the summation of x equal to summation of all the force equal to 0. Then we have Bx have minus 1 because this is opposite to your x uh, direction. So negative is equal to 0. Finally, we have Bx is equal to 1. So which means that it agree with our direction. Now we can use method of join to find all the remaining member forces. So a joint A, we have, remember that our sign convention is always in tension. So for tension, we always point outward the joint or away from the joint. And remember, compression is towards the joint. So this will be FAC this will be FAD, which is positive. Okay, which means that we assume that they are in tension. If our value is negative, then we'll consider compression. Okay, so generally we don't want to write that because you'll get confused. So just know that if it is pointing away from the joint, it is tension. And this will be your AY. So if we take, and this is theta, so if we take F summation of all Fy equal to 0, we'll have FAD y component and then plus AY equal to 0. So FAD sine theta plus AY is equal to 0. And we already have AY, which is 2 over 3. So if we do the calculation, you'll find that FAD will be equal to minus 0.83 or 0.83 compression. But for this case, we don't have to worry whether it's compression or tension. All we need is a sign and the magnitude of the force. And then we did summation of all the x equal to 0. So in this case, you'll find that it is FAD x component plus FAC equal to 0. So FAD cos theta plus FAC equal to 0. And we already find our AD is minus 0.83. And if we calculate, you'll find that these are not capital F, these are all small f. Okay, so please don't make the same mistake. These are all virtual load or unit load methods, so all of these are small letter f. Okay, so you'll find that your FAC will be equal to 0.5. Okay, so that is your FAC. We'll take for the another joint. It is your joint B, and if it is joint B, then again this is theta, and then this is bx, and this is by. Then in this case, this is FBD. Sorry, this is FBD. This is FBC. So this also will be small f, small f. Okay. So now summation of Fy equal to 0. So you have FBD y component plus By equal to 0, and By is minus 2 over 3. So FBD y component is sine theta minus 2 over 3 equal to 0, and you'll say FBD is equal to 0.83 kips. And then we'll see the sigma of Fx equal to 0. So you'll have minus FBC minus FBD x plus Bx is equal to 0. This will be FBD cos theta plus Bx is equal to 0. And we know our Bx is equal to 1. And then FBD is equal to 0.83. So FBC will be equal to 0.5 kips. But at joint C, because these are collinear, so if two member forces are collinear or two forces are collinear, then the third one will be 0. So in this case, your third one will be equal to 0. Okay, so if the third one is equal to 0, then we can also say that your FAC must be equal to FCB. Okay, so you'll see that here also your FAC, which is 0.5, must be equal to FBC, which is also 0.5. So in that way, you verify that what you are doing so far is correct. Okay, so because FBC and F AC are the same. So finally we can write our delta H, sorry, the final horizontal join at D will be equal to twice of your twice AE, um, your F is 0.5 for BC and AC, and then the force is 75 and the length is 15 feet plus 1 over AE, and this is for AD. AD is minus 0.83 and 49.59 or 0.56, and then this is 25 feet, and then we have plus 1 over AE 0.83, this is for BD, and then we have minus 2.91 into 25. Okay, so that's what we have given here. So we have summed them together because these are equal force, so we sum them together, and then we have the AD and BD. Okay, so that's what we did there. And then if you sum them all together, you will get this is equal to 1414.86 kips feet, and we have here AE, and AE we all define the value of AE. If you put the value is 0.5 feet, and because it is positive, that means it will agree to our assumed direction of deflection. How did we assume that it is to the left? Because when we are applying a unit load, we apply the unit load in this direction, and because it is positive, so that means this direction is the actual direction that it will deflect. Okay, so what does that mean? That means that when you're applying this load 42 and 28, this joint will move a bit over here. Okay, so it will move in the direction where you apply your 28 kips. Okay, so that's how you do the deflection. That's how you calculated the deflection of a joint in a truss due to the external load. Okay, so that is all about external load. Now we're going to see what if there's a change in temperature. Okay, so if there's a change in temperature, please make sure that you read the question carefully, because it's very important, so that you don't waste all of your time in doing extra thing that is not needed. Okay, so it is given here that again same horizontal deflection at D, and the member AD increases by 20 degree, and the member BD increases by decreases by 20 degrees centigrade. What does it mean? That means that your delta T for AD will be equal to 20 degree, and delta T for BD will be equal to minus 20 degrees centigrade. And now, knowing that that AD and BD are the only member in their truss that undergo temperature change, then the rest of the member did not go any under temperature change, so we don't need to include them in our calculation. So what I mean by that, it means that if you write delta H D is a summation of Fi delta L I, and in this case it will be summation of Fi alpha, which is your thermal coefficient expansion, Li delta T I. So this will be thermal coefficient expansion will be the same. This will be F L delta T for AD plus F L delta T for BD. Okay, And because we already found the um, unit load for the same deflection in at a joint D in horizontal, so I don't need to calculate it again. But in case in your exam you have to calculate the member forces F due to your external load. So here, if I do all the calculation together, I'll get equal to minus 0.83 into 25 into 20 alpha plus alpha 0.83 into 25 minus 20, and if I sum them together, I'll get putting all the alpha together, you'll get minus 830, and then alpha is 12 into 10 minus 6. And because I use this as feet, so I know that our deflection will be feet. So finally I'll find that this is 9.96 10 to the power minus 3 feet, or we say 9.96 10 to the power minus 3 feet in the other direction. Okay, so positive negative mean it should be the reverse direction that you assume. Remember that for finding the unit load member forces F, we applying a unit load 1 kilonewton. So but we get negative, so because we get negative, that means the HT actual should be in this opposite direction. And you can tell that like whether it's true or not. We say that AD is temperature rises, and BD temperature drop. So if AD temperature rises, that means this will expand here, and BD will uh, undergo temperature reduction, so it will shrink. So basically it will be, so you see that it does move to the right. Okay, so that so in that way you can make sense that why it is negative. Okay, so that is the truss deflection unit using unit load method due to temperature change. Okay, so final one is the truss deflection for the same truss. For the same truss, we are interested to find deflection, so that's where we're going to apply 1 kilonewton again for unit load, and we're going to find the F value for each member. Okay, and we know that this is V zero force member. Okay, so again, when it comes to temperature change or misfit, please make sure that you read the question carefully. Okay, so in this case, it says that the member AD is too short by 0.2 feet, and the member BD is 2.2 feet long. So if it is too short, negative; it is too long, positive. Okay, so just like we did in temperature change, we'll have delta H D will be equal to summation of Fi delta L I, and because only BD and AD undergone misfit or fabrication error, so that means only AD plus BD will be in your calculation, and the rest will be 0. Okay, so we already calculated the unit load, so it will be minus 0.2 plus 0.83 into 0.2, and this will give you 0.33 feet. That means it will deflected in this direction, your horizontal horizontal joint at D. Okay, so your deflection, horizontal deflection on joint D, it will move in the direction where you apply your unit load. And let's see whether it makes sense or not. AD is too short, so AD is too short, so it'll be over here, and BD is too long, so it's over here. So that means finally your net deflection will be exactly moving towards your left. So that is all about truss deflection using unit load method for your FE.